So we have, in a typical process, we have inputs to our system and then outputs, okay? Now, inputs might be things that we can change or manipulate. Outputs are going to be things like measurements or measured or unmeasured outputs from that. So this is our system right here. Now, we try often to form a model of our system, okay? So those are sometimes collections of differential or algebraic equations, okay? So we have a model. Okay, so this is our model of the system, okay? We can put those same inputs that we measure into our model and then predict outputs as well. Okay, this is the true system, the physical system that we're trying to model. Sometimes we don't get these inputs quite right, but let's say just for assumption that we know those inputs, and now we want to try to align our outputs, our measurements, or certain parameters. Okay, so I'm going to say this is a parameter P right here that is a true system parameter, and then we have an estimated system parameter as well to try to align it to the to the reality. Okay, so how do we do this? I want to get you guys' feedback on this. What are some methods to align align these outputs, okay, and also these parameters, okay? So the system states, we'll call those the states of the system, and then also aligning aligning parameters. Okay, so let me open that up. Any ideas on how we can align those? Okay, so Risa says it gets the inputs and the outputs. Okay, so we have measured inputs and measured outputs, and then we align them. Okay, so good. So we're using the information from the inputs and outputs. Any other ideas, guys? So let me throw out one simple one, okay? I'm just going to throw out a very simple one, which is, let's say we have a measurement, and then in our model, one of the things that we can do is just do an additive bias, okay? We can just say, well, you know what? I have a difference. I'm going to put this as X for my output, and then X predicted, and then X measured. Okay, I could just do a bias. Okay, so I say my X predicted. Let me do a bias. Okay, can you guys still see that? Okay, bias equals, and then I'm just going to do the difference between the two, which is going to be X measured minus X predicted. Okay, and then I can have a biased model output. Okay, X, I'll say X hat. Okay, equals X predicted plus bias. Okay, so that would be one way of doing it, of aligning it. Just saying, you know what, I'm off by 2. Let me just go ahead and add 2 to my predictions. And then I'll say that that is going to be, I have a model value, and then here's my measured value. And let's say I just shift everything up into the future by 2. Okay, so that'd be one way of doing it. We're going to talk a little bit more about some methods to be able to align these. In particular, we're going to be looking at a technique called moving horizon estimation. Okay, moving horizon estimation. And what we're going to do, instead of just applying a simple bias to our model, we're actually going to use optimization to help us determine certain parameters. Okay, so we're going to try to determine these parameters and then also improved predictions of our output. Okay, so we're going to form an optimization problem. So if I'm going to minimize something, what would I want to minimize in this system? Okay, so I'm just going to write a standard optimization problem. Minimize f of x, which is my objective function, subject to I'm going to write some equality constraints and then some inequality constraints as well. So for moving horizon estimation, what is my optimization problem in this case? What am I trying to minimize? Okay, so Risa says error. Okay, and you guys need to unmute your microphone if you're going to participate. You know, don't forget that it's muted if you have the red icon next to your name. Okay, good. So so Risa says we want to minimize the bias here. Okay, so I'm gonna just say minimize bias. Okay, now if I minimize my bias directly, it's going to try to put my x prediction at infinity, right? Because then the bias will go to negative infinity, and I'll minimize my. So I might need to do something like minimize my bias squared, okay? Or you know, maybe a more standard form, minimize you know, my x prediction minus my x measured squared. So sum of squared errors. Okay, I'm trying to minimize a sum of squared errors of my differences between my measured and my model values. Okay, so I may have you know, not just one measurement, but I also may have multiple measurements along the way. And so I want to try to minimize the summation, not just one value, but I'll write a summation there of all of my measurement and predicted values. Okay, so that, and then we need to make that subject to, okay, subject to our model equations. Okay, so that's the basic idea behind moving horizon estimation. We have some measurements of our system. We know that our model is not entirely accurate. So what we're going to do is go ahead and try to estimate some of these parameters from our model, or estimate some of the output states. Okay, and we can adjust. So one of the things that we can adjust within our model are either the initial states. Okay, we can adjust this value up or down. Okay, or we can adjust our parameters as well, our parameters within our model, and try to get it to start tracking, start tracking these measurements a little bit better. Okay, so we're going to do this in Simulink, and okay, so go ahead and come to the PRISM website. It's apm.byu.edu. Okay, if you just go to that, you can see, you can go to the PRISM group webpage and come down here to APM software, and then you have demonstration files in Simulink, and that will download it for you to your computer. Okay, so go ahead and grab those right here at the bottom. If anybody has trouble getting those, just let me know, and I can try to email those to you as well. Okay, so let's just spend just a minute, make sure everybody's got those. Okay, and once you get them, go ahead and unzip them on your desktop or somewhere else that you can run these from, and we'll go ahead and start going through this this simulation. Okay, I have all of the files worked out right here, but let's first of all, before we open up, before we open up this one, let's go ahead and just go to Matlab. We'll kind of start from scratch here, just to, I'll show you our system that we're going to try to simulate here. So go ahead and open up Matlab, and then type Simulink once you get there.
Dr. Henninger, I couldn't get the files.
Oh, you couldn't get the files? Okay, so were you able to come to this website here, Jose?
The Prism website?
Yeah, the Prism website.
Yeah, but it's not the same. It's not the updated one. I'm on apm.byu.edu. Is that it?
Yeah, that's it. And then come over here to APM software. Right here on the bottom left, you'll see APM software, and then you'll have demonstration files and Simulink at the very bottom. You may need to click refresh if your browser, your browser is.
Oh, okay, I see it.
You have them now?
Yeah, which one do you click on?
Go ahead and open up demonstration files and Simulink. And it's under projects, APM software, and then demonstration files. Okay. Jose, do you have those now?
Yeah, I'll get them. I'll just thanks.
Okay, and let me know and I can email them to you if you're having trouble getting them from the website. Okay, so anybody else as well, if you're having trouble getting them, just go ahead and send me an email. Or send me just tell me. I'll send you an email. Sorry. Okay, so let's just go ahead and create a new sheet here. Okay, and if you guys get stuck, or you can always go back to the Simulink file that I gave you. Okay, so what we want to do first of all is go ahead and just open up your library browser, and again, if you guys get stuck, just let me know and send something in the chat window, and I can slow down or try to help you. We're going to drag over the transfer function. Okay, so if you can't bring the library browser up, then just go over to View and then Library Browser. You can also do Control-Shift-L, and it'll bring up your library browser for you. Okay, so if you can't get the library browser up. Okay, now first of all, I'm just going to drag over. I'm going to go to Continuous here and drag over a transfer function. You can also, if you can't find that, you can also just look for transfer. Okay, search for transfer, and it'll do transfer function. Okay, so you can do it either way, searching for it. And we're going to put a transfer function over here. Okay, now this is going to be our process. Okay, I'm going to go ahead and relabel this. I'm going to make this just a little bit bigger here so you guys can see it on the screen. I'm just going to name this process right here. Okay, and then I'm going to have I'm going to change this process. Let's go ahead and give it a gain of 5 and a time constant of let's do 3. Okay. Actually, yeah, I think that'll be good. A gain of 5, time constant of 3. Okay, so that's in the Laplace domain, a transfer function that relates inputs to outputs, just a single input to a single output. And now we need to also drag in maybe a step, okay, for our input. Let's go ahead and just drag in a step. It's also listed under, if you guys need to find it, it's also listed under sources, okay, and that will be the step signal there. Or you can just go up to your search thing at the top and search for step. Okay, so I'm going to do a step time. I'm going to start this step at 3. Initial value of 0, final value, let's say, of 2. And we're going to go ahead and click Apply. Okay, now go ahead and drag that over. And then we want to also be able to view this, so I'm going to do a scope as well. Okay, it's also listed in sinks. Okay, sources are sinks. Sinks are the outputs, sources are the inputs. And then I'm just going to drag over a scope, okay? So this is my output. Okay, and then I'm going to go ahead and link those up, and then I'm going to say, let's simulate out for 20 seconds, 20 time units there, and just go ahead and simulate our system. Okay, so a little warning message there. I think everything is okay. Let's just go ahead and see that. There's my step that started from 3 and went to 10. Okay, yeah, maybe I want to see both the inputs and the outputs on the same plot. Okay, so I'm going to do a mux, okay, here, and grab both the input and the output and send them into one plot there. Okay, so I'm going to have my output here, and then also, right-click this, and then you can bring something off. And you want to be able to combine those two signals into one. Okay, so I have my input and my output coming through. Let me go a little bit slower on this, in case some of you missed it. Go to mux, okay, and then you can find that in commonly used blocks, and you search for it. I think it highlights it there, commonly used blocks. But just search for MUX.
It's also under signal routing.
Okay, signal routing. Reza says it's also under signal routing. Okay, so let's go ahead and, so this is no longer my just output. I'm going to call that response. If I simulate it, then I can see both my input and my output on one plot. Okay, so this is our system. So Reza has different colors. He has purple for his step versus yellow for his response. It just means that he probably switched the order. He put the input coming in as a second variable instead of the first. So it's anyway.
The output is the first one.
Okay. Okay, so that's our system now. Now what I want to do is have a model. We want to have a model of our process, and then use moving horizon estimation to be able to estimate certain parameters or variables within that model. Okay, so what we want to do now is we still want the step there. Okay, we still want the step, and we still want to be able to view the response. Okay, but we're going to add something new now. Okay, we're going to add a triggered system, and the triggered system is going to estimate the well, okay, so we're going to estimate some parameters within this model. Okay, let's just start with one parameter. We'll just try to estimate the gain. We won't have a perfect knowledge of it, but we'll have something close, and then use measurements. These are like the measurements coming out of the system. We use these measurements to update our process model using a sum of squared errors. Okay, a sum of squared errors approach. Okay, so what we want to do now is go ahead and view our library browser and look for triggered. Okay, triggered subsystem. Okay, I'm gonna drag this down. Okay, so the reason why we have to use a triggered subsystem is we don't want to calculate. We only want to calculate the MHE at certain points along the way. Okay, we don't want to calculate it continuously every 0.0001 seconds. You know, something very, very small, because you know, it'd take too long. Okay, so maybe every in this case we'll do it every about 0.2 seconds. Okay, we'll do 0.2 seconds, and then try to use this data that's coming out of here to estimate this gain. Okay, so I'm going to in this triggered subsystem, we also we have some inputs and then outputs. Our inputs in this case are going to be the measured going to be the measured state from the process. Okay, and then what's going to be coming out is we're going to try to estimate this parameter right here. Okay, so go ahead and does everybody have the triggered subsystem? If you don't have the triggered subsystem, just let me know. You can search here again for triggered. Okay, triggered right here, and then drag over the triggered subsystem. Okay, and then the other thing we're going to need is a pulse. Okay, a pulse generator. We need to tell it when to start this, triggered subsystem. Okay, so I'm just going to rename this as pulse. Okay, search for pulse in the Simulink browser. Okay, yeah, let's plug in Reese's laptop here. Let's see. Okay, browser's back here. Okay, and then let's connect our pulse up to this triggered subsystem. Okay, we can rename this one. This one's going to be MHE, or Moving Horizon Estimation. Okay, and then double click on your pulse and set the period to be 0.2. Okay, every 0.2 seconds we'll have a new estimate for this parameter. Okay, and pulse width, that one doesn't matter. Pulse delay, you don't have to put that in, as we'll just leave it as 0. Okay, and then go ahead and click OK. Okay, now we'll also we just want to see this pulse. I'll just copy that. You can do a Control-C, Control-V. Let's just you right-click off of this and drag it over to your other response. I'll do a pulse watch. Okay, we'll just look at what our pulse is doing, and then if we come to our triggered subsystem now, this pulse is going to be triggering this to go every 0.2 seconds. If I double-click this now and double-click my trigger, okay, double-click my trigger, I'm going to trigger on the rising part of the pulse. Okay, so you could do it on falling. Okay, I'm just going to do it on rising for this one. Okay, so and then let's rename our inputs here. Okay, we have signal attributes here. Actually, let me rename it down. I wonder if I can rename it here. So this is going to be my this is my output. Okay, my output from my. I'm going to say that this is my measurement. Okay, and then this is my parameter. Okay, so right now this triggered subsystem, all that it's doing is boy, those are kind of big. I need to make this a little bit bigger here. This pulse watches. Okay, I'm going to drag that over, just a little bit of housekeeping there, just to keep things neat. So I have my measurement that's coming in from my system, and then I'm going to try to produce a new parameter here and try to estimate that. Okay, so let's go ahead and open this back up again. Go ahead and double click it. You'll see that right now my measurement is just coming in, and it's just saying my parameter equals my measurement. There's nothing in there in between there. Okay, so now we want to delete this line, and we want to put our estimator right here. Okay, so in this case, let's see, what is the name of that? The custom function. Let's see if I can remember that. Okay, user-defined function. Reza says, okay, and we just want to do a interpretive Matlab function. So this allows us to just create a script and be able to run that script. Okay, so we're gonna go ahead and this is going to be our moving horizon estimation. I'm going to make this a little bit bigger, guys. Horizon estimation. Okay, you can put whatever name you want there. That it doesn't matter. I'm going to make this a little bit bigger and just adjust it over. Okay, so hopefully everybody's still following. If I need to slow down a little bit, just let me know. I'll just review that because I know sometimes it's hard to listen and do things at the same time. But just type in interpreted, or you can come here to user-defined functions and then drag over the interpretive Matlab function. Okay, so the thing that's going to be coming in is going to be called measurement, and the thing that's going to be coming out is my parameter. I only have one of each of those, okay? And then I'm going to go back to my system now. Let's go ahead and save this. You know, we've done a lot of work on it already. I'm just going to put it in that same folder that we had that we downloaded, okay? So if I come here, you'll see I already have a process.slx. Okay, now you might, if you have an older version of Matlab, it might be an MDL file instead. That's fine. Don't name it process. Name it, you know, put your name there because it's going to be your own MHE. Okay, we'll use some of these files but go ahead and open this up, and then double click on the moving horizon estimation in the triggered subsystem. And right now the function is sine. Okay, it's just a sine function. What we're going to do is go ahead and replace that with estimator. Okay, we're going to have estimator.m. Okay, and then let's go ahead and minimize this. I'm going to go over to my folder that has now my own Simulink module, and then I've created already for you the moving horizon estimation script. Okay, so go ahead and open this one up, the estimator estimator.m, and you know, I'm going to go through this in just a little bit of detail. I didn't want to necessarily have us all type this out because it would have taken too long. So go ahead and just use this script right here. And actually, we can probably simplify this. We do need to change some things in this to be able to use it. You know, actually, let's go ahead and save this as you know. Save as you know, estimator new. Okay, go ahead and do a new estimator file here. We've got to put in the U value as well here. Okay, so instead of it being a global U control, so I had another problem set up with a controller and an estimator there. Go ahead and delete the global U control and then rename this as input 2. So we're going to have two inputs that are going to come in. We're going to have the measured output and then also the measured input from our system, the U value and the X value. Okay, so it only runs through this section the first time. Okay, if this value hasn't been defined yet, I defined it as persistent, so it'll stick around even between function calls. Okay, then I'm also defining my server and application names. The first thing I do is load my APM library. Okay, so that's just the this folder right here, a collection of MATLAB calls that we need. We don't have to do anything with that, just load it here, define my server, define my application. Okay, now it looked like that. Hopefully this is going to work as well. Let me just make sure our website is working right now. Because okay, so that one is working. The XPS one was working. For some reason, the APMonitor server was not working. Okay, then I'm going to define an application name. You guys can change that. I'm going to just put an underbar my name just to define it uniquely. And then I'm going to call an estimator initialization here. It only does that the first time. I'll show you guys that file in just a little bit. Here are my measurements, measuring both my output and my input, and then I'm solving it. I give it the solve command, and then I display the solver output. The next thing I do is just check to make sure that it was a good solution. I also get the CPU time that it took to solve, and then I display those on a line. Okay, so these lines are optional right here. It's just for display. And then I have my output, which is my new value, my new gain value. Okay. Okay, and then if it's the first time as well, if it's the first time running through, it's just going to also run this. It's going to open up a web viewer for me, and then it's going to turn on the feedback status after it's initialized, and then set this estimator initialized to true, so it doesn't visit this section anymore and doesn't visit this section anymore. So when it comes through next time, it's just going to define my XMES and UMES for my two inputs, and then it's going to insert those with the APMES function, solve it, and then retrieve the output. So it's really the estimator is just doing this each cycle.
So then for the first time, the F status is off, which is 0 on the first cycle.
Okay, yeah. So Riza just had a question why the F status is off on the first cycle. You know, sometimes this triggered subsystem, it executes first before the model has a chance to simulate, so you might have bad measurement values just on that first cycle. Okay, so I just turned F status, the feedback status, off just for that first cycle, just to initialize the model, and then the next cycle, it's going to turn that back on and start again. Okay, good question there. Let me just show you guys the estimator init. Okay, now this one we had estimator new. We also have to come back up here and change our function name here. Okay, or else it's going to complain at us a little bit. So just at the very top, just name that to estimator new or whatever you guys defined it as. Okay, so let me show you the estimator. You guys can open this up as well if you want. The estimator init. Okay, this is just going to do a couple different things. You know what? Let's save this as estimator new init. Okay, we got a couple changes here. We don't need the global U control anymore. Okay, make sure you change your function name because you changed the file name. Okay, and then we're going to clear anything that was on the server previously by that application name. We're going to load our model that we have. Okay, this is the representation that we have of our process with differential algebraic equations. We're going to load a time horizon as well. That's estimator.csv. If you open it up in a notepad, it just shows the time horizon. I'm just going to go back in time 3 seconds in 0.2 second intervals. Okay, so you can put in, you could also put in, let's say you had U values over that time horizon. You could also put in, you know, those U values, you know, 1, 2, you know, things like that. It's just a CSV file. We're just going to specify the time in this case. The U values are going to come from the Simulink model. Okay, so I'm gonna close that, and then the other thing that's important is this this interval here, 0.2 seconds matches your triggered subsystem, so that Simulink is executing this every 0.2 seconds in the simulation. It agrees with your time horizon here that you have in your data file. Okay, so you have a model file and you have a data file. Here's your model file. Here's your data file. Okay, just specifying a time horizon. I'm going to define some parameters. I could estimate tau as well, k and tau. Here are my manipulated variables, my inputs to my model u. Okay, so k and tau. K is the numerator from, let me go back here. So k should be equal to 5, and tau should be equal to 3. Okay, that would be the true values of our process parameters. Let me open up the model as well. So this is how you define that same model in APM. You have tau of 5. Let's just change that to 3, and then we'll say k is 2. Okay, so our actual k is 5. But we're going to say, you know what, we're going to start with a guess value of 2 and see if the optimizer can hone in on the correct value for the gain.
The process model that we put in the transfer function represents the process model, in the APMonitor represents the model in the control.
That's right. So yeah, there are a lot of times you'll be using the same model for a controller, and so we're trying to estimate these parameters for the controller. So this would be representative of what our model would be in the controller instead. Okay. And then I have my equation. This is just in the time form. You know, the first order linear system that relates x to u. This $sign is the differential dx dt. Okay, so there's my model. Actually, let me save this as, I'm going to save this as, because I had some other parameters in there. I'm going to do a save as, oh, I just saved all. Should save as. I'll do model new here, okay, and then I'm going to go back to my, I don't remember what these parameters were from my previous one. Did I have 5 and 3 there? I don't remember. Anyway, I'll show you guys that example later. We'll change those. We have tau of 3, which is the correct value. This is an incorrect value, but we'll try to estimate it. Okay, so we have model new.apm. Okay, and now go back into your editor that you have, and we'll just load in our model new instead. Okay, so go back into estimator new init, and then we'll load in our model new.apm. So let's see. So Jay, if you haven't opened an APM file before, it's just a text editable file. You can open it with any text editor. I'm just showing it here with, you know, this is just using Notepad++ with some syntax highlighting. Okay. Okay, is there anybody behind right now? Do I need to slow down, or is everybody okay?
I'm good.
I think I'm as caught up as I'm going to be.
Okay, okay. Joseph said he's as caught up as he's going to be. Okay, that's good. So I know we've been jumping back and forth between a couple different things here. You know, Simulink, Matlab, APM. So it's okay if you guys have questions, because it's likely that others have questions as well. So don't feel bad about asking questions. Okay, so okay, then what we want to do is we also want to see our response from this. We want to see the k value that comes out. Okay, so this is my estimated k value that's going to come out of this. I have measurement coming in, parameter coming out. Okay, and then within the moving horizon estimation, I need to change this to estimator new now instead of estimator. So we defined a new function here. Okay, so go ahead and do that by just double clicking on your MHE, double click on this, and then you'll see estimator there. Change that to estimator underbar new.
So do we need to put 2 inputs into our estimator function?
You are right, Abe. Thank you. Okay. Let's come in here, double click on measurement. Okay, and then go to signal attributes, and then port dimensions, change that to 2. Okay, so that's, I'll do that one more time just in case you guys missed it. And I'm just going to change this name to, I'll just leave it as measurement. Signal attributes, and then port dimensions 2. Just double click on that input. Okay, thanks, Abe. That was important observation there. Okay, and then in light of Abe's comment, we also need to put another MUX in there, MUX. Okay. See if I can select the right thing here. Okay, combine 2 signals now. It's not just going to be one. You're going to be taking the measurement coming here from the output. Okay. And then we also need the input that's measured as well. And that will become our measurement that comes in. Okay, so let me let you guys do that. I'll let you get, I know I just went through a couple things pretty quickly there, but we need to have 2 things coming in here, not just one. We have measurement and then also parameter going out. Okay, so I think I'm about ready to try it. I mean, you know, it gets to a certain point where I just think, I know there's some bug left, but I might as well run it and have the interpreter tell me where the bug is rather than fishing around for it. So I'm gonna try it, guys. I'm just gonna go out to, you know, I'm just gonna go out to 5, and it's going to go every 0.2 seconds. Okay. Actually, let's see. Do I have any other? Yeah, I'm going to try it. Okay. So error. Okay. Good. So we got an error. There's a block error. Undefined function or variable. Estimator new. Okay. Let's see if I can. Let's see if I can find that. One of the things we've got to make sure if we open up Matlab that we're in the right folder here. So it couldn't find that because we're not in the right folder. If you go back to your Matlab screen, so what you need to do is just change your directory to that Matlab folder that we're using because it couldn't find the function. Okay, so just go ahead and select it, copy your path, and then once you do that, then all of your things will show up in the left-hand corner here under your current folder. Okay, so everybody have that. Go back to your Matlab. Make sure your path is set correctly, that you have the correct path set here. Just go to your folder that you were using, copy the path. Just do a Control-C on that path, and then paste it in right here at the top. Okay. Okay, then I'm going to go back to my Simulink now. I'm going to try to do it one more time. I'm expecting another bug. Okay, that one didn't look too bad. Okay, so this is the zoom. I just zoomed in a little bit on that. Let's just see if it solved. It looks like it solved. We'll go and see if we have any good results there. I have 151 variables, 150 equations, leaving 1 degree of freedom. And you can see that the solver solved it in 2 iterations. It looked like it converged pretty quickly, solution time 0.03 seconds. And there's my final objective function value. Okay, so let's look at our x value to see how well we're predicting. Okay, so I went out to 3 seconds. You know, so my simulation started and I went out to 5, right? So I kind of started here, then after 3 seconds, it started. And then let's see the current K value right now. So K value started there, and it's reached about 6.7, but it definitely increased from 3. Okay, so Riza has some different results. If you guys see that, you guys may need to, if you've run the script once, you have to come back into Matlab and do a clear all, okay, to clear out your initialization, and then you can run your Simulink again, and then you'll probably see some better results here. Okay, or more consistent ones. Oh, you know what? You gotta. Oh, there it is. Okay, so it's updating there. Okay, so it's it tried to track that. Okay, and it started to get a better value of our gain. Not perfect yet, but as it gets more values, we'll start to see hopefully that it'll it'll improve the estimation. Let's go ahead and okay. So let's take some questions here. Do all of you have this up now? Do you have this estimator work? If not, let me go ahead and post this to the website, and you guys can just take my files, and then you'll get caught up to where I am right now. Let's see. Okay, so what I'm going to do is I'm just going to post these files again. I'm just going to close out my stuff. I'm going to save everything. I'll go ahead and post these files again to that link, and then you guys can just go and grab them if you guys are behind or don't have it quite working perfectly yet. Okay, so I'm just going to go back to the Prism site, and I'll just post a new link there with these updated files. Okay, so they're there now. If you guys need to get caught up to where we are, you can always just go and download version 2 now on the demonstration files. Just go ahead and download those up, unzip them, and then you can open up john.slx. If you have an older version of Matlab, it may not work because I think SLX is the newer one.
So if we were wanting to estimate tau as well on this, would we just add it in as another parameter?
Yeah, you'd add that in as a another parameter. Well, let's go ahead and do that. That's great. Abe, why don't I let you present now? Do you want to try that? Abe, do you want to try that? I know I'm putting you on the spot.
Sure, I can give it a try.
Okay, so we're going to help coach Abe through this, guys, and see if we can add another parameter that we're going to try to estimate at the same time. Okay, so Abe, go ahead and click Share My Desktop when you're ready, and then we can see your desktop and try to work through this. Okay.
Okay. let's see. Let me see where I found put that at.
Don't worry about, yeah, you're good if you need to.
Let's see. So would we just set it up in the initialization file?
Mm-hmm. That's exactly right.
Like here we've got our parameters.
Yep.
I think like basically the same thing as this, right?
Yeah, you're just going to replace all the K's with taus there. So let me explain those parameters that go with each of them. Status just means you're turning it on, saying, you know, I want to use that in my estimation to try to minimize that sum of squared errors or other, you know, error model that I have. F status means the feedback status for that parameter means I'm not measuring that parameter. I'm just estimating. I'm not using any measurement from my system to be able to determine that. I have a lower and upper value as well. You might want to, on the tau, just set the lower value to 1. If it goes to 0, I think bad things would happen. I don't know, you know, turn into an algebraic equation instead. And then upper, and then Dmax is a rate of change limit. So I'm saying every iteration, don't change that parameter by more than 1. Okay, yeah, you could leave that out if you wanted to. Okay, so then for you, the set point, set up MV right below it. So that in that case, we're doing the opposite of what we did for the parameters. We're telling it that we want the status to be off. So we don't want to try to let the optimizer optimize that value, but we do want to use the measurement for U. Okay, we're going to be measuring that. We know the control input, but we don't want to try to use that to minimize the sum of squared errors. Okay, good. I think that is what we need to do. Then we need to put another output. Yeah, go back to estimator new. Let's see any other changes that we need to make there. Okay, so I'll let you try to walk through that, Abe.
Okay. Just be this output here, right?
That's right. Yeah, just that output right there.
Just do output 2.
Yep.
Tau.
That's it. I think you've got it. Okay, so we have one measurement coming in, or actually 2 measurements. We have the U value and the X value. And we're going to be trying to estimate 2 parameters, K and tau. Now you need to adjust something in your Simulink model too. And you picked up on it earlier for our input measurements, but you need to adjust that.
How do we get 2 outputs out of that? Do we just also, any idea why my Simulink has strange colors on it?
I don't know. That is a good question. Anybody seen that before? Okay, well, you must have a special version of it or something. I don't know.
Okay, so we change the dimensions on this output port, I guess, to 2.
Yep, I think that's it.
Okay. And would we have to put like some kind of splitter thing on this signal as well?
You know, you can just feed it right into the scope, and then you can see both the.
Okay.
So instead of estimated K, you can just put estimated parameters if you wanted to.
Okay.
Okay, now let's go ahead and do a clear all from your Matlab, just to.
Okay.
Okay, so you got clear all, and then go ahead and run that again. hopefully it'll pop up a web viewer. And let's look at our K and then also their tau values there. Okay. So it went down initially. Let's look at our tau value too.
There you go.
Okay, and maybe let's look at our X value too. Okay, so it found a solution that was able to minimize that sum of squared errors, but it kind of went to some different values. So Abe, let's try one thing now. Go back to your Matlab.
Okay.
Your Matlab and just do a clear all there on the Matlab interface, the script. We'll go ahead and clear it, and then go back to your Simulink block, and let's just put in. Go ahead and copy your pulse and replace your step input with a pulse input. Okay, great. And then let's adjust. There you go. Good. And let's go ahead and adjust this. You know, maybe a period of let's say 3 seconds.
Okay.
Okay, or I guess maybe 5. Let's do 5 or so, and then pulse width do 50%. Pulse width there. Okay, and then go ahead and click apply. So we're going to adjust. So instead of just a step, we're going to give the input to our system a pulse. Okay, we're going to make it a pulse. Okay, go ahead and click OK, and then simulate maybe out for 20 seconds instead. Okay, just to be able to see a couple of these happen. Okay, and then go ahead and click go, and let's see if it's able to maybe do a little bit better job of estimating these. So we'll see it as it goes, kind of in a sequential fashion, you know, getting new measurements, new data, and we'll see how good it does in terms of estimating, estimating these. So we gave it a pulse input. So we've got our K value and then our tau value. So it looked like it was off a little bit when it makes those steps, but I was able to get fairly good alignment there between the measured and model values. There might be some kind of interesting. Okay, so let's just see what it kind of the values went to for our K value and our tau value there.
Okay. Like it kind of, mostly it was between 5 and 6.
Oh, okay. Hey, Risa found an error for us. Let's go back to your script for estimator new. Okay, and then in here, okay, scroll down just a little bit. So he says line 20, we have an error there, where we need to. Let's see, is that the same line 20? So scroll up a little bit there.
It's upper.
Okay, you already put that in there. Estimator, new init, good. Okay, you got that in there. I didn't have that in mine, and so we just Risa caught that. Okay, so go back to your plots one more time. Let's just take a look at those. What did the gain turn out to be then? It was kind of fluctuated a little bit as it stepped up and down.
Kind of like
it kind of went.
Mostly.
Yeah, 5 and 6. Okay, so the true value was 5, but there, because it's a triggered subsystem, it only executes every 0.2 seconds. Maybe that was some of the issue. Look at your tau value as well. Let's just take a look at that one. should have gone to about 3. And so yeah, it looks like it was doing some fun things with, you know, maybe some collinear parameters there, where you can change both of them and get nearly the same solution. Okay, but it kind of settled out to about 3, kind of during the when it wasn't changing drastically. So,
cool.
All right, guys. Well, that is Abe. Let me have you just zip up yours. I'll make a version 3, and then everybody can have the one that you just worked on right there. You know, I'll post that to the website as well. Okay, guys. Let me show you one more thing while Abe's zipping that up. I'm going to go ahead and take the presenter privileges back, Abe. Okay, and if you go ahead and open up process, we're not going to run through this. You know, we're out of time for this tutorial, but I'll just show you how to, you know, link up this estimator with something like a model predictive controller as well. Okay, so here's just a slightly different system simulation. You have a gain of 5 and a time constant of 2. And I don't think I put any model mismatch in this one, but you could. And then I have a measured output coming in here. And the input to my moving horizon estimation is this, you know, this measurement, okay? And then the output is going to be my updated parameters. And then I'm going to feed in the measurement plus that updated parameter into a model predictive controller. Okay, so you have the estimator.m, which is this one. Okay, that's estimator.m. The other one is going to be controller.m. We're not going to go over that one, but if you guys are interested in looking at it, you just look at controller.m function, and it will show you how to do the model predictive controller. So instead of us specifying, you know, the input coming into the system, the controller is doing that, but it's using the same model and same techniques that we showed with the moving horizon estimation. So I'm just going to simulate this for, I'll go maybe 5 seconds on this one, and then we can see you know, the controller at work here. So here's the controller. It's trying to drive the system to somewhere between 10 and 9. Okay, so it's trying to drive it. There's a little bit of a model mismatch there, and our estimator is taking care of that. So it'll open up 2 panels here. One is going to be the estimator, okay, trying to align our model with our measurement. Okay, it's doing a good job with that. And then our controller, once we get that update, then it feeds those values to the controller, and then the controller tries to drive it to our new targets. Okay, so that's kind of the other application. We're not going to go over that today, but you guys have that as an example if you'd like to look at it. Okay, so let me just review what we've covered today. We set up a simulation. Okay, just did a step on our simulation, and just gave it a source, you know, a step or you know, or some sort of pulse, and then viewed the response. Okay, that was just kind of the first thing, is setting up our simulation. Now we also set up an estimator that then takes as inputs the measurements from our system to try to update certain parameters or other variables in our model. This final simulation showed how you can then take those parameters, update a controller, and then use that to drive your system to a particular target value, okay, or a range of target values. Okay, so I'll open it up for any questions that you guys might have. You guys have any questions about this? Okay, well, I think we're about done then.
I have a comment.
Okay.
So, I mean, on a first principles model, you can do any of this for any type of model, right?
Yeah, you can do it for any. Just for simplicity, I just showed a linear model here. But yeah, this could be a very nonlinear collection of differential and algebraic equations. And this simulation block here, you could also replace that with like an S function if you want to use the Matlab integrators, or you could also put another APM block in here and use that to say I have these inputs coming in, I have these outputs coming out, and use a dynamic model there, similar to how we did this function here. Okay, so yeah, you have a lot of, Jose's right, you have a lot of different options here for the types of systems that you can simulate with this. You can do nonlinear, you have mixed integer decisions here on the MHE or the model predictive control. Jose, was that kind of what you were asking?
Yeah, that was it.
Okay, great.
Yeah, I found it not later.
Okay.
It's because here, for the first one, I was working input the second one output. So it was.
Oh, it switched. Okay, so Riza had an error in his model. He had switched the order of the inputs.
The orders are very important.
The orders are very important. That's right. Okay, guys. Hey, I'll post that version 3 once once Abe sends that, and then you guys can go and download that, and then you'll have all the files that we worked with today.